So in the last clip we saw which were the strong acids and which were the strong bases, and we've seen this slide many times before, and I'd just like to point out that these 2 points have always been the second point and the third point out of 3, and it's still in light gray because we've never talked about point 1. And before we can talk about point 1, we really need to introduce some terminology. So if you have an acid and it reacts with a base, they're going to react, and what's going to happen is the acid will lose a proton, become A minus. The base will gain the proton to become HB. And the A minus is no longer an acid. It's lost its H plus. And the HB now is an acid because it has an H plus. And they bear the following names. The A minus is the conjugate base. It's not an acid because it's lost the H plus. And the HB is an acid now. It is the conjugate acid. And with this terminology that an acid and base react to make the conjugate base and the conjugate acid, we can understand rule number 1. And rule number 1 applies to when is an acid-base reaction favorable? And the answer is that it's always favorable if the acid HA is a stronger acid than the conjugate acid, HB. If HA is a stronger acid than HB, the reaction is favorable. And equally true, you can look at the bases. If B minus, the base, is a stronger base than A minus, then if the base is stronger than the conjugate base, then again, the reaction is favorable. So the rule is an acid will turn into a weaker acid in a favorable reaction. In a favorable reaction, a base will turn into a weaker base. And by favorable, we mean, here, let me put that here. By favorable, we mean when the reaction is all said and done, it's reached completion, greater than 50% of the reactants have reacted. That's the exact definition of favorable. Good. So now let's use what we know about strong acids, strong bases, conjugate acids, conjugate bases, and we can look at the first problem. HCl plus F minus going to Cl minus plus HF. This is the acid, and HF is the conjugate acid. And is this reaction favorable? Put it in chat. And the answer is yes, it's favorable. Why? Because HCl is a strong acid. So the strong acid is turning into a weaker acid. And HF is not a strong acid. And that is an amazing fact, and you really have to wait. Really have to wait to a later chemistry course to learn the reason why HF is not a strong acid. Okay, let's look at the next one. H2SO4 plus H2O going to HSO4 minus plus H3O plus. H2SO4 is the acid. Put in chat which of the reactants products, which of the products is the conjugate acid. Put it in chat. Put it in chat. And the strong, the conjugate acid is H3O plus. And so, yes, again, this is a strong acid. H2SO4 is one of the strong acids. It is therefore stronger than H3O plus, and therefore, again, it is favorable. Third example, HSO4 minus plus H2O going to SO4 2 minus going to H3O plus. This is the acid. This is the conjugate acid. And is this reaction favorable? Put it in chat. And the answer is, put it in chat, not favorable. Why is that? Because this is not a strong acid. It's not on our list. Okay. Let's just do one last one. And it's a little tricky, this last one. It's because of the way it's written. It's NH4Cl plus BaO. Well, first, right off the hat, we say the BaO, we know this is a strong base. We're about to have an acid-base reaction if you got a strong base there, maybe. And this is going to, and the thing is, it goes to NH3 plus BaCl2 plus H2O. There's a third product. But is this reaction favorable or not? Put it in chat. We have, as one of the reactants, a strong base. And is this going to be a favorable reaction? And I guess the one way to look at it is that the acid portion is this port. This is the acid, the NH4. NH4 plus is the acid, which makes NH3 the what? What is the NH3? If NH4 plus is the acid, it makes this the conjugate base. And so, since the conjugate base is much weaker than the original base, this reaction is indeed favorable.